So here we have this set, 42, 43, 44, 45, 46, 47, 48, 49, and 50. And it states from the set of numbers above, write down the multiple of 7 that is also a perfect square. So let's list off our multiples of 7. Multiples of 7 are 7, 14, 21, 28, 35, 42, 49, 56, 63, 70, 77, 84, and so on. And let's list off the perfect squares. So perfect squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, 100, 121, 144, and the list goes on. But how do we get our perfect squares? Well, 1 times 1 is 1, so 1 is a perfect square. 2 times 2 is 4, so 4 is a perfect square. 3 times 3 is 9, so 9 is a perfect square. 4 times 4 is 16, so 16 is a perfect square. 5 times 5 is 25, so 25 is a perfect square. 6 times 6 is 36, so 36 is a perfect square. 7 times 7 is 49, so 49 is a perfect square. 8 times 8 is 64, so 64 is a perfect square. 9 times 9 is 81, so 81 is a perfect square. 10 times 10 is 100, so 100 is a perfect square. And the list goes on. So that's how we get our perfect squares, right? So what they want is they want a number from the set that is both a multiple of 7 and also a perfect square. Now, if we look carefully, we would see that 49 is a multiple of 7 and 49 is also a perfect square. And so that means that our answer here is 49. Next, the question states, from the set of numbers above, write down the prime number that is also a factor of 215. Now, prime numbers are numbers that have only two factors, 1 and itself. And so 43 is a prime number from the set, but is 43 a factor of 215? So what we could do is we could divide. So we say 215 divided by 43, and 215 divided by 43 is 5. 5 is a whole number, so it has no remainders when we divide. And so that means that 43 is indeed a factor of 215. So 43 is not only a prime number, because it only has two factors, one in itself, but 43 is also a factor of 215. And so that means that our answer here is going to be 43. And that's our answer to this question.